Hello everyone. Today we're going to start a new data structure, stack. So stack is a special kind of list, but it has a special feature. So stack is a list. We're saying stack is a list. So you can see that it's a list of item. But stack operates in a special feature known as last in, first out. Last in, first out. So just let us look at some example. Okay, so let's think about a stack of coin. All right, there we have a stack of plate or stack of book. Okay, so in a stack we insert an item here. The next item will be inserted at the top of this item, then third item, fourth item, fifth item, like this. So this is our first item. So this is our second, third, fourth, fifth item, like this. Now if we want to insert another item, we are going to insert the sixth item at top of the fifth item. So a stack means like a stack of items. Okay, so like this stack of items. So now let's look at this stack. Okay, so in this stack, this was actually our first item, this is our last item, and this is our first item. All right, now let's say I want to pick a coin from this stack. Okay, means I want to remove, or I want to pick a coin from this stack of coin. Which item I'm going to pick? Okay, so which item I'm going to remove from the stack? So in this stack I'm going to pick this item. Okay, means the last one. So which item I'm going to delete? I'm going to delete the last item. Okay, now that's why this is known as last in, first out. Okay, so this is your first item, this is your second, this is your third, this is your fourth. So this fourth item is the last item. But if I'm going to remove a item, I'm going to pick the fourth item. Okay, so I'm going to pick the fourth item, means the last item, because this is at the top of the stack. This item is at the top of the stack. All right, so when I want to delete this, the first item I can delete is the last item that I had inserted. All right, so that's why this list operates in a last in, first out. All right, so insertion deletion can be performed only from one end. So if I want to delete something, I can delete the item that is at the top of the stack. Okay, so in this stack, this is the top item, and the top item I inserted that at the last. But if I want to remove any item from the stack, the item I can remove first is the item that is at the top of the stack, means the last item that I inserted at this stack. Okay, so you can see that I cannot just pick any item from the middle. All right, and that is going to destroy the whole stack. All right, so that's why stack is a special data structure, a list type data structure that operates in a special order, where the order is last in, first out. All right, and in short, we can remember what is the order like that. LIFO, LIFO means last in, first out. All right, so the last added item has to be removed first. All right, so in every data structure, we are going to know about what kind of operation we are going to implement in that data structure. Now, stack is a list of item. Now, for every list, we have to have some operation, like we want to insert items, we want to remove items, we may want to look at the items. All right, means we want to read items, and we want to check whether this stack is empty or not. Now, in a stack data structure, the insertion means adding an item has a special name known as push. Push means insertion a item at the stack. So now think about that. Let's see, this is our stack. All right. So this is our first item. This is second item, third, and fourth. And I want to insert a new item. Okay, where I'm going to insert that? I'm going to insert at the top of the stack. So this is my fifth item that I just inserted. And this operation is known as push. Pop means delete the item from top of the stack. All right. So if I want to delete an item, I have to pick the item from the top of the stack. So currently in this stack, I have 5 items. So this is the item which is at the top. So this is the item I can only delete. Okay. And this operation is known as pop. So after the pop operation, there is going to be in the stack, this item will be deleted and there will be the rest of the items like this. There will be these 4 items. Pick means read the item at the top of the stack. Now, if I have like a stack, you can see that which item just I can read. I can just look at the top of the stack and I can look at the which item is at the top of the stack. So reading from a stack means I can only look at the top of the stack. Okay, so this operation is known as pick. Pick is reading the item at the top of the stack. IsEmpty is the operation by which we can find out whether the stack is empty or not. All right, now it's a very important thing is that all the operations should be preferably implemented in order of 1 runtime. All right, means we want to implement all of the operation in constant runtime. So very important properties of stack, always remember LIFO. Insertion and deletion flows in last in, first out fashion. Okay, the last item placed on the stack will be the first item removed. Okay, so it's similar to stack of dishes, stack of coin, or stack of books. If we have a stack of book, I cannot just pick any item. I cannot just remove any item at the middle of the stack. This is going to destroy the whole stack. The item I will remove from the top of the stack. Okay, and this is the item actually that was inserted last. So that's why it is known as last in, first out. So let's see the stack operation. First, the simulation of stack operation, how the stack is going to look like after operation. So let's say we have an empty stack. Empty stack means we don't have anything. So we are pushing a item in the stack. Here we are pushing a value 10. Then push another item 20. So 20 will be here. Push 30. 30 we are pushing at the top of the stack. Now just look at this stack. Our top value is okay. Now this is our top of stack. Now we are pushing 40. So now this is our top of stack. Push 50. 50 will be at the top of 40. Now this is our top. So you can see that whenever we're maintaining the stack, we have to always know, I mean, after each operation, after each push or pop operation, we have to always keep track of the item which is at the top of the stack. All right. Now let's see, this is our existing stack. Okay, we are going to see how the pop operation works. Pop means delete operation. Okay, so this is actually our pop operation. So pop operation. Now pop operation doesn't need any parameter. Pop means I want to remove the item that is at the top of the stack. So look at this function. Pop doesn't need any parameter, because when I'm trying to delete something from the stack, always remember the only item I can delete from the stack which is at the top of the stack. Okay, so in this pop operation, if I run a pop operation, that is going to delete the item that is at the top of the stack, and which is 50. All right. So again, let's run another pop. Okay, the first pop, it removed 50. Okay, so after I removed 50, I have now, this is my existing stack. Okay, now run another pop operation. This is going to remove 40. All right, now this is my top. Okay, so run another pop. Okay, this will remove 30 and this will be my top. Okay, so another pop, so this will remove 20 and now this will be my top. Okay, another pop, so after this pop operation my stack will be empty. Okay, let's see one example. Let's see, I have an empty stack and I'm running few push and pop operation. Okay, so let's see, these are the operation I'm running in order. Say push 10, push 20, push 30, pop, let's make it 40, pop, all right. All right, so this we are starting with an empty stack, means nothing in the stack, and these are the set of operations we are running in the stack in order. Okay, now I'm asking, what is the find the top of stack? Okay, so let's look at the how my stack is look like. Okay, so after each operation, push 10, push 20. Okay, so after I push 10, this is my top. Now this is my 20, this is my top. Push 30. Now this is the top. Pop. Pop means this is going to pop. This is going to remove which one? 30. Okay. Now again, 20 will be my top. All right. Another pop. So this is going to remove 20. You can see that 20 is at the top of the stack. Okay. So now 10 will be my current top. Okay. Then I am again pushing 40. So now in my stack, I have 10, 40, and 40 will be top. Again pop, so it will pop 40. Now 10 is again my top. Push 50, so push 50. Now I have 10, 50, and 50 is my top. Push 60. 60 is my top. Okay, then again pop. So pop is going to delete 60. So what is my top of the stack? 50. So at this moment, find the top of stack is 50. So after each of the operation, my stack is actually looks like this, 10 and 50. Okay, and 50 is the top. All right, so this is a sample question. I mean, this is a sample question we can look like, we can find out in exam, or also when we're going to implement stack, we have to understand how after each operation stack is going to look like. Okay. So in the next segment, we are going to look at the implementation of a stack. So remember, like when we are going to implement each data structure, we're going to implement that as an abstract data type. All right, means we're going to define a class. Now stack is a list. All right, so stack is a list, but it has special feature. So that's why the operation we are going to implement in the stack, we already listed that. Okay, sorry. So in the implementation of stack, we're going to have this feature: push, pop, peek. Peek is actually peek is going to read the item. Peek, or we also sometimes known as top of the stack. Okay, so this is going to just read. This is not going to this is going to read which item is at the top of the stack. All right, so just remember, peek or top, that will not modify the current stack. This will just return, this will just read the item at the top of the stack, and we can check whether the stack is empty or not. All right, and each operation we have to just preferably we want to implement each of the operation as order of one runtime. All right, and we are going to look at different type of implementation in our next segment.